Hi, everyone. Thanks for joining the WildFly community call for December 4th. Let's start with the community announcement. So we have updated the schedule for WildFly 39 beta. Do you want to give a word about that, Brian?
Yeah, we excuse me, we pushed it out a week. So for all the people doing development work on 39, for the beta, which is the due date basically for new feature work, we need to have PRs ready by the 10th, so a week from yesterday. And then we'll do it's the normal Space Saver releases where we'll tag and deploy a week later. So it'll be out available on the 18th. We might push out the final release in January by a week. That's not clear yet. We haven't decided to do that yet. So as of today, it's still meant to come out, I believe the 13th, 14th of January. We'll see though.
Okay. Yeah, there's a longer time between the beta and the final due to the end of your break.
Yes.
Okay, thanks. Then the main point on the agenda today is Emmanuel that will present what we have been doing around generative AI in WildFly. Emmanuel, do you want to share your slides?
Yeah, I'll start presenting.
Thanks. Okay.
Hello. So I'm Emmanuel, and I work a bit around providing a feature pack for WildFly to help with generative AI and all around what the AI hype that we have today. So I have multiple things in this feature pack, and I will try to cover them. First, so the WildFly AI feature pack is using mostly a lot of LangChain4j underneath. So you will see, what you will see is how we make it easier to use LangChain4j in WildFly, providing a lot of way for you to easier way to avoid a lot of plumbing and boilerplate code. And for this, we are also using a sub-project of LangChain4j, which is called LangChain4j CDI. And as the name implies, it tries to expose LangChain4j objects or components through as a CDI object that can be injected in your code. And it provides also extension to help with so they use microprofile config for configuration, and they try to also provide fault tolerance using microprofile fault tolerance. And there is some microprofile open telemetry. So those are extensions to the LangChain4j CDI core project, and to be deployed in a microprofile runtime. So just a quick recap on LangChain4j. LangChain4j provides basic elements to help, so to connect to and exchange with an LLM. So it can provide a way to send messages, prompts to the LLM, provides prompt templates, a way to keep the chat memory available to pass it to the context. It provides us also tools for RAG, for retrieval aggregated augmenter, and so it provides way for you to split your documents, create some embeddings from them, and store those contents and embeddings in an embedding database or vector database, and so that you can get meaningful content to enrich the context based on some semantic search, usually. And it has higher level components, such as tools, which tools or functions that can be called from the LLM. So when I say tools, it means we could say Longchain4j tools, which are specific to Longchain4j, or this could be MCP tools, as we will see later on. It provides also AI services, which is a way to have a higher level component on top of that. And this is something that we can provide also as part of WildFly. So, yeah. So, what is RAG? Because one of the main usage of the WildFly AI feature pack is to provide a way for you to do RAG, so retrieval augmented generation. So the idea is to get data that is pertinent to the current context for the prompt that the user sent. So this is just a recap schema from Longchain4j. So you get a query, and from that, you will create an embedding. So an embedding is a vector that provides semantic analysis of the query. And based on this vector, it will look into an embedding store, so something that has a vector as key, let's say, and content as value. And it will look for the vectors that are the closest to the one that you prompt, and will get relevant segments, relevant part of some documentation, for example, and send the query plus all those elements to the LLM for it to generate the answer. So this is what we have in WildFly for this. So we have support for several chat models. So chat models is connection to different LLM. We have one for, well, yeah, the list is not exhaustive. It's just some examples, but we have one for OpenAI or OpenAI API, I would say. For Olama, Gemini, but it's not here. Mistral, GrokQ, GitHub models, etc. So we provide a lot of those, and we can, of course, augment, increase the number of models depending on the usage. Currently, I think we have around 6 or 7 such models. We have also support for embedding models. So embedding models are models that are here to compute the embeddings from the query or from the content. For that, we provide 8 in-memory embedding models. So there are very small models that can run inside the GVM and will generate those embeddings for you. And so that we don't depend on the embedding store to compute them and select them, but we only rely on our code. And we also provide a way to use Olama for that. But like for chat models, I mean, we can create that number depending on the usage. We also support embedding stores. So that's vector database, mostly where we can store those embeddings and those content. I would say the demo one is the in-memory embedding store, which is basically a JSON file back embedding store, and is used in memory for small contents. We have also support for several embedding stores such as Deviate, ChromaDB, and also Neo4j. And Neo4j is not used, I would say, in the classic way, but it can be used for GraphQL queries. So instead, that's what people call now GraphRag. And so for this, also you have to have something that is able to to compute the embedding of the query, select the embeddings from the embedding store from them, and get them back and get the content back. That's the role of the content retriever. And we provide 3 different control retrievers. One for, it's a default embedding content retriever, so that uses what I said about the fact that we are looking for content by semantic proximity. one for Neo4j. So here the idea that so it's GraphRag is that it will use the graph model of Neo4j, so the one that you have defined in Neo4j, and will compute using a small model, a small dedicated model, compute a GraphQL query to get the content that is meaningful. And of course, you have what we call web search engine. So basically, it's well, one of them is Google. Basically, you send the query to Google and get back a few say document or content, and you are using that as content to be added to your context. So that's, I would say, the generative AI right part. And of course, we have also the what we call tools or functions that can be called by the LLM. So we have support for the app2 annotation from Generative. And we have support for MCP as a client, so that we can connect to an MCP server using stdio, SSE, or streamable. And we have also, like I said, that in Longchain4j CDI, they provide OpenTelemetry integration. And so we have this, I would say, automatically working in WildFly, in that if you define, if you add the OpenTelemetry subsystem to WildFly, automatically the WildFly AI feature pack will connect the Longchain4j code to OpenTelemetry, so that you have metrics and traces on each query to the LLM. And last, we have also support for a session-based memory. So like I said, there is this idea of having a chat memory for a user to keep a track of all the interaction with the LLM. What we provide is a way for that to be bound to the HTTP session for you. And that's, I would say, something that is quite stable and working properly. And we have also features that are more experimental, two of which are, one is to provide an MCP server. So the idea here is that we are going to try to expose some code. So let's say your existing application code that has some business function, and we want to expose that to the LLM. So here is what we do is we provide a way for you to annotate your code and expose that as an MCP tool to be consumed by LLM. So it can be, of course, your agent application running WildFly AI feature pack with the generative AI part, or it can be another agent in whatever language. So currently we support tools, resource, and prompts. And we have basic support. So we don't support stdio because the std out of WildFly is not something that you can interact with easily. So we support for SSE and streamable. Of course, like I said, we don't support everything, and we need to expand that, also depending on what people want to do with it. And down to that, in a way, is WebM, so WebAssembly WASI. So that's the WebAssembly part that is running on server side, not on the browser, in the browser, but in the server side support. So this one is pretty limited, but it works. So the idea that you build a WebM binary using whatever language you want, so it can be Go, it can be Rust, and it will be able to be exposed as a CDI being that you can call a function on in WildFly. And if you have the WebM subsystem and the MCP server available, then it is exposed as an MCP tool. So you can call Go binary in WildFly as a MCP function. So that's a quick recap of everything we talked. RAG components, so embeddings, modem, store, and retrievers. Chat memory, that's for RAG. MCP client and MCP server. Just, I'm going to show you a bit of code before going into the demo. So here is something where we can inject some code. So you can see that we are here injecting by name. That's the name of the resource in the WildFly configuration. And here in that case, we are using this content retriever as part of the post construct of the bin to construct a retriever augmentor. So it's something that will be able to do the RAG part. And you can see that we can use a prompt template where the elements will be replaced during each call. As I said, we are ready to support Longchain4j AI services. So an AI service is basically an interface upon which we will build a proxy, a JDK proxy. So we have our own annotation, which comes from Longchain4j CDI, which is registered AI service, in which you define the chat model you want to use. In that case, it's Olama. You can define tools, which are Java classes in your application that are annotated with Longchain4j add tool, or you can define the scope. And as you can see, we have a single empty method that will take a system message, so that's the one that is passed to every query to the LLM, and takes a user message, which is in that case is the string that is passed as a parameter of the chat function. So that is basically this is an agent that can call Olama, provide some tools for Olama to call back, so, and is directly usable and injectable in your application. This is the same. Well, the same. This is another AI service. But it's a bit different because instead of Olama, you can see it's using Mistral, and that it provides a tool provider. So the tool provider is a way for us to provide MCP client integration. So in that case, this I will show you afterwards. But the MCP is the name of a resource in the WildFly configuration, configuring which tools we want to use. And the little difference with the one before is that this one is a streaming one. That means that we are receiving, previously we were returning a string. That means that we will return the full answer from the LLM once we have it, we will receive all of it. While here, we are returning a token stream. So a token stream means that we will get tokens from the LLM bit by bit when the LLM sends it back. So that makes it more interactive when you are waiting for the answer. You can see the answer coming back from the LLM. So that was for the AI generative AI part, and that's for the MCP. So here is how we declare something to be used, to be exposed, either as an MCP prompt, that's the first one, MCP resource, so basically a file, that's the second one, sorry, the third one, and in the third one we have an MCP tool. So this is an add tool annotation, but it is a different one from the Longchain4j add tool. And you can see here that it's taking tool and tool arg, and it will. So you need a description, and the description is used when generating the schema for the tool, because MCP tools are exposed as JSON schema, and so this schema is exposed to the LLM for it to know when to call the tool and how to call it. And all this is configurable through WildFly management model. So that's the XML part. Here you can see we have our streaming Mistral model. You can see that it's marked as streaming true over there. Yeah. So it shows this one is going to be streaming, and so you will have token stream. That's for debug. You can log request and response. You can select the model you want to use on APK and a bunch of other parameters. Of course, those are very basic, but you can define temperature. You can define, depending on each model, you can define all the parameters that are bound to that model. So some are cross, I would say cross model, and some are specific to each model. So that's the chat part. So the connection to the LLM. Here we have the in-memory embedding model. So that, like I told you before, so that's a small model that we load in memory, and we will compute embeddings. So here it's a, you can see it's a, well, that's the name. And we have each one have a different module, because even if those are small models, those are big jars. So we have a module per model, and you have the name that you can use also to inject or to reuse across the configuration. Here we have the embedding store. So in that case, it's a simple file, because it's a in-memory embedding store. And here we have the content retriever. So the content retriever connects to an embedding store. So it's an embedding store content retriever, so it connects to an embedding store. So here we are defining the embedding store as in-memory, which is this name, as the link. And also the embedding model we are going to use to compute the embeddings for querying the embedding store. So there it is. And while you can define how many results you want, what proximity score you want to filter out the result, and to because of course the more you get, the more your context is grows, and so the more it costs you. And here you have the MCP client configuration. So that's for the configuration to connect to an MCP server. So we have an MCP tool provider. The MCP name we saw previously. So that's the MCP that is here. And it has a list of MCP clients. So each client is a connection to an MCP server. In that case, we have only one, which is an MCP SSE. And this MCP SSE here is, as its name shows, it's a MCP client using server-sent events. And it's going to connect to a server which is with a socket binding that is defined later on in the WildFly configuration. And that's the SSE path. If you don't use the default one, you can redefine it here. So now let's see some demo. So first, I'm going to share my console. I hope it's readable. Okay, so I'm going just to show you the.
Sorry, Emmanuel, can you make that a bit bigger? Otherwise, I think we won't be able to do that on the recording. Thank you.
Is that better? Okay. So here we have a simple application. So it's using WildFly documentation as base for RAG. So there is a dedicated project that we just download the documentation from the web, split it, and then create the embeddings for it and store it in a JVM file, which we will use here. So it's a very basic application that we are just building in front of you. And here you can see that it is using Glow underneath. Here it is. So it is using Wi-Fi 38.0.1 final and using the AI feature pack 0.8.1, sorry. And here you can see all the layers that are going to be used. So we are training the server according to your use of the server, so that you don't, for example, you don't get all the embeddings modeled in your running server, because, like I said, they are quite huge jars. Several, I think it's more than 100 megabytes. So each one. So that's why it's important to be able to trim. So, sorry. Here we have the core AE server and JAX-RS, because of course we are exposing JAX-RS endpoints. And we are using chat memory. We're connecting to Olama as a locally, globally as getting the full answer and streaming. I will try to show you both. And I'm using the default embedding content retriever, which is I would say an easy layer to bind everything together for the case where we want to demo. So it's using an in-memory embedding store and the in-memory embedding, the in-memory embedding, the Olama, sorry, all MILM L6v2 embedding model. So okay, so just let's get started. Okay, just to show you, here you can see all the CDI beans being created, chat memory provider, embedding model, etc. The server is started, so I'm going to share. Yeah, that one. Oh no, closed. So, so that one is the classic RAG. So in that case, we are using Olama, so it's going to be slow. So I'm going to ask the question before talking, so that we can wait for it. So how do I connect? How do I create a connection factory to a remote Artemis server? So I will show you afterwards. So that's the query. So now, because it's Olama and it's running on my laptop and I don't have a huge GPU, it takes quite some time to get the answer. So you can see we are using WebSocket, but even if we are using WebSocket, we are not using token stream here. That's why it takes that long. And what I can show you is the log of the trace in the meanwhile. Here you can see, so that's the query we have sent. So you can see the request sent to the LLM. So I'm going to use Olama on that port and URL with Llama 3.1 8 billion. So that's a small model for Llama 3, quite old. And here you can see, so that's my system prompt. Sorry, yeah, it is. That's a system prompt that the query I sent, or do I create a connection factory to a remote Artemis server? And here is some content retrieved from the embedding store. Those are a few parameters. So you can see here that we are not streaming the answer, and this is temperature. And now we got the answer. So we have everything back from the LLM. So that's I want you just to see that you can have the answer and the request and the response on the log if you want. And if I go back, no, this is oh no, sorry, wrong. Here we have doesn't show, but I don't know if you can read it. But here you have the final the same response here sent back from the LLM. This display here. Now on the same application, so I'm going to share the other one. Okay. Here, so this one is not doing a RAG, but it's connected to the same model. And we have a simple question, which is, what is the best sci-fi movie? Okay. And this one is using streaming, and you can see the difference in terms of UX, user experience, when it's token stream versus when it's a full response. So you could see quickly the message, sorry, the tokens or the strings coming and being displayed, and that makes it more interactive. Okay, so that was for the RAG part. Now, let's see. Oh, let's see for the MCP part. So I'm going to show you the console again. Okay. So this is a different application. Initially, it's called WildFly weather, but because initially the first example that was displayed for MCP was some weather tooling where you could ask for alerts on US states. So what I'm going to do is again build the application. So it's also still using Glow under the hood, and you can see here that we are just using MCP server and WASM because I will show you how you can how we are exposing binaries, WASM binaries in it. So it's very, very, very basic, and oh, sorry, I didn't use the proper. Yeah, because there's a small bug that I fixed this morning. So in the headers, it doesn't change much. Okay, so now I can start it. So for those who are familiar with MCP, there is a tool which is called MCP Inspector provided by Anthropic that can help with showing what tools can do. So I have one here. Okay, so that's the MCP Inspector. So I'm going to connect to my server, and so you can use resource templates, etc. So you can see, I have disabled authentication for demo, but it works with OAuth security, and you have a way for you to define it. And here you can see the tools. So here is the list of tools that we have. So that's the weather one. This one is written in Java. So for example, let's say I want to have alerts in California. And here you can get the answer from some government service in the US, which tells you all the alerts, process visa, advisory, etc., etc. So looks like there is some coastal flood that might happen in the North Bay, but okay. And in the same way, what we can do is, so a roll is a Go module, which roll dice. So I want to say, okay, I have three dice and of 6 faces, and it will execute them. So this is executed through Raven, and in the same way we have the grid written in Rust. So if I say WildFly, yeah, and last but least, if you are looking for an own pizza in Grenoble, where I live, you can see that there are 3 places: Toscana, Pizzeria della Bella Italia, e Lo Napoli. And so those tools were written in Rust, in Go, and were exposed through Wagon. And well, they are quite basic, but yeah. And also we can have Java written code that is exposed as an MCP tool to be consumed. So it can be AI use streamable, but I could use SSE in exactly the same way and have it working. I'm just going to show you just a bit what you can see on the console. I don't. Well, so that one was the weather. So you can see all the messages that were sent back from the MCP server. So that was the initialized connection. So that's where the MCP server tells the MCP client what it supports. You can see it's in our root.war application. Well, default server is the name of the Undertow server. We can provide tools, resources, and prompts. And that's the protocol version that we support currently. And here is the MCP call. So here you have the schema that is defining what the tool can do. So you can see it's called alerts. It can get weather alerts for US state. Its input schema is a property which is a kind of string, and you can have description here, and it is required. Then I won't show you all the tools, because those are all the tools you can see. And here is the message being sent. That is the answer after the call to the tool itself. I won't show you more, but that's, you can see the answer that we have seen. That was the 8 of the dice roll, etc., etc. And what I can show you too is the configuration. So that is standalone.xml. So here we have, sorry, here it is. So that's standalone.xml. So we have our MCP server. I'm going to show you. So MCP is the MCP configuration is very simple. It says that we are going to expose the MCP server. So those are the endpoints that we are exposing. Those are so streamable is exposed on stream. Messages on messages. That's the old one. And SSE on SSE. So that this will be automatically added to your application context if you have several applications, because currently we are using root, So it's going to be slash messages slash SSE slash stream. But if you are not in root, but in I don't know, MCP, for example, then it will be a slash MCP slash messages slash MCP slash SSE, etc., etc. The name here is to be appended to the application context. And I wanted to show you, here it is. This is the WAVM configuration. So we have some chicory underneath, under the hood here. So you can see here I'm using those pass-through binaries here. And so we have a grid WASM and a roll dice WASM. So those are just binaries that are executed in the GVM. And here you can see there is also the pizza one, and the pizza one has already host star. Sorry, because we are going to do a call to a remote server. So we need. Sorry, we need to allow it to get out of the sandbox. And here it is. I can give you the link to the source code if you really want the Go source code or the next one. I have also some. That's basically it. So you can see it's very easy to define WASM. That's the name, and you can inject them using CDI if you want not to use them as MCP tool, but just want to use them in your application code. So you can inject with that name, and of course, they are, because there is a WASM subsystem, they are exposed as WASM tool. So I'm going back.
Sorry, Emmanuel, I have a question. Let's say, for example, in WildFly, I'm using it as a backend and I want to expose my application as an MCP tool. If I understand correctly, I need to update my deployment applications to provide the tool annotations to MCP.
Yep.
And provide the binding between the schema expected by MCP to my API, right?
Yeah, so sorry. I don't. This is what you need to do. Okay. So you have just to add the add tool. I mean, all the schema will be generated by WildFly, so you don't have to provide any schema or anything or any JSON. We will generate it from the annotation that you're providing here.
Okay, I think I get confused because you are using an MCP tool to call LLM to give you information about the weather, but what I can do is just call my backend.
It's not calling an LLM, it's calling an online service from the US government.
Okay, but it can be my own deployment. It can be my own business objects.
Yeah,
okay.
Yeah, exactly. I mean, but it's just because this is it's a bit more complex than what you see here, because the weather client is getting from the two-letter US. I think it's getting some coordinates to send to the service itself. So that's why it's you don't the weather client does a lot of things underneath, and it's business method.
Okay.
But here we are just exposing the business method. Yeah, that is defined in the weather client get alerts. All the business code is here, and it's not displayed here. We are just, this is more to expose it. So I would say, in a classic way, you could just expose your business code through a new method, and which will hold all the annotations part.
Okay.
I'm sure. Is it clear?
Thanks.
Okay. And just wanted to show you, because it is global, then it's very simple to configure. So here, here you have the Go configuration to see what we can do. So what's next in the AI feature pack? So one thing is to expand it by providing more providers. So for connecting to more models, to connecting to more embedding store or more embedding models. So that's one way for it to evolve. Another way is to have more microprofile integration, because WildFly is Jakarta lead, but also microprofile, so we can try to take advantage of that. For fault tolerance, the fault tolerance one is a bit tricky because Longchain4j has its own retry mechanism. So if you have fault tolerance retrying something that is retrying, the context tends to grow, and you have to make sure that the retry doesn't keep the chat memory from the previous failure. Otherwise, you have 2 or 3 times the same prompt in it, or maybe same, so with the context, etc., etc. So it can be huge and doesn't provide any value. We have to follow MCP specification change. So there have been updates to MCP specification. So I need to update the current MCP module to make it up to date with the specification. And also there are some capabilities that currently we don't provide. Like, for example, you can set from the MCP claim, you can set the log level on the MCP tool, and that's not something that is easy to have in our case. One thing also that might make sense to add to the WildFly AI feature pack is the A2A in terms of A2A integration. So currently there is a project in WildFly Extra by Kabir that provides A2A for Jakarta IE application. So that's a library that you can add to your RAR to have an A2A. So A2A is agent-to-agent protocol, is a way for you to connect to or to connect with agents. And for example, if you want to orchestrate several agents, you could do that. But that the goal is to be able to make that better integrated into WildFly, just like Longchain4j is integrated through the AI feature pack. So in conclusion, we can
sorry, Emmanuel, I just have a question. When you say that you want to add more provider, is it pluggable? For example, let's say there's a new provider, a new LLM that you want to discuss with. Should that be done inside the AI feature pack, or can I provide like a JDBC, for example, bring my own driver and having the feature pack? Can I do Longchain4j?
No, because initially, there was some discussion about that at the initial step of the WildFly AI feature pack, because we were discussing about the fact that, as I say, each LLM might have its own parameters. So currently, no, we have a selected few ones, which are the main ones, and those are, I would say, are exposed through the WildFly management model. It's not dynamic in that way, because there is no there is a common interface in terms of Longchain4j object, but the configuration is different for each one of them, and that's why it's you can't have something generic, or you would have you could have if you have a map with a key value for each parameter, but then you wouldn't be able to ensure that the parameters are correct and that are the proper one that you want to use. So the validation that you have with the management model, well, that's one of the advantages if you have validation. The drawback is that you can't easily expand. We have layers, so you can take advantage of those to trim down the server to your exact needs. We are using CDI injection, so so it's easy for you to you don't have to go all the way to the AI service. You can just use the beans or the parts that you want. And if you don't want to use AI service, but you want to link all your parts manually yourself, you can do that also. AI service support. And you have seen that you have MCP client and MCP server support. Just some links to the resources. So to Longchain4j, to MCP, so Longchain4j CDI. We are hoping to have at least 1.0.0 alpha version to be released soon, soon being this week or next one, and to go to a 1.0 GA by the beginning of next year. There are several blog posts I've wrote about all I've shown you today. A2A specification and Kabir project, which provide a SDK to have A2A in Java in Jakarta server. And I guess
I'm also adding a reference in the agenda with the WildFly catalog, where you can see the AI feature pack and all the layers it provides. It's a comprehensive list of what is actually provided by the feature pack.
Yeah. Forgot about that one, but yeah, it's we support the catalog. Any questions?
Thanks.
Yeah, I have one question, Emmanuel. Have you guys been doing any performance evaluation for these prompts when we during the chat sessions, for example? Has there been any considerations with like separate thread pooling and how it's impacting other applications when it's running chat sessions, holding the threads and etc.?
No, I must admit, no, we haven't done that. Also, currently we are using our own thread pool from Longchain4j. The goal is to be able to use the thread pool from WildFly to be able to inject them, but we have to define how to do that in a way that is cross runtime possible, so that it works both in Jakarta EE and in microprofile. So that's why you can inject the managed executor service, for example. But no, I haven't looked at the impact in terms of performance.
Okay.
Okay, I'm sorry, we're a bit running out of time. Thanks, Emmanuel, for the demo. And if there's any questions, we can discuss that on the WildFly user groups or the WildFly dev mailing list. Before the end of the meeting, I just wanted to show. Let me share my screen again.
Yeah.
If I can. So yeah, we had the discussions about GraalVM and WildFly that is happening at the moment. It's interesting things that Jean-François is looking if we can make WildFly run as a native executable. That would have a huge benefit on the cloud. So it's an ongoing deep research project. And I just wanted to point out that with Thanksgiving and Christmas, we are a bit changing our schedule for the community call. So the next one will be on the 18th of December, because we won't do one on Christmas Day, and then it will resume every 2 weeks on January. Okay. Thanks everyone for the attendance, and thanks Emmanuel for the presentation. And if there's any other questions, please post them on Google user groups or on the WildFly dev mailing list. Thank you very much. Bye everyone.
Bye-bye.
Thank you.
Thank you.
Thanks.
Bye-bye.